So limits are a really important part of calculus in that they allow us to deal with parts of functions that are really difficult to deal with. So one of the reasons we use them is for dealing with asymptotes and holes, discontinuous points, and later on we're going to use it to deal with instantaneous slope. Okay, so instantaneous slope meaning when we have a rise and run that are both 0 and 0. So it's really hard to figure out what exactly the slope is when we're dealing with those points. So we're going to start with the main parts, so just dealing with the parts of graphs that we've already seen. So holes, asymptotes, and points of discontinuity. Okay, so we have to deal with limits in this way, in that we have to have left and right hand limits. Okay, because when things are going, when we have these graphs, especially these funny graphs, okay, so these are a little bit maybe new to you, but these graphs that are kind of all disjointed and stuff, we're going to have to be able to deal with these types of functions. So to deal with these functions, we need to establish that we have right hand and left hand limits. Okay, because if you take a look at some of these points, for example, this first point at x equals 3, notice that as we approach 3 from the positive side, the value of that function is different than as we approach from the left-hand side. Okay, so we use these right and left-handed limits. So here, if we look at this right-hand limit, so I'm just going to start with a right-handed limit here. So the notation is this: the limit as x approaches some value from the right side. So here I've got x approaches 3, and this plus means not positive 3, but approaches 3 from the positive side. And if we look at that, it means that we are approaching the function from this side. Okay, so there's my function. It's approaching the value of x equals 3, and it looks like the y coordinate is approaching negative 3. Okay, so negative 3 is there. Now, this is different than if I'm approaching the limit from the the left-hand side. So this notation here indicates I'm approaching the value of 3, positive 3. That negative means approaching it from the left side. Okay, so this is our limit notation. Okay, so that indicates a left-hand side limit. So as I approach from this side, I'm approaching a different value. I'm approaching a value of y equals 2. So the limit from that side is equal to 2. The limit from this side here is equal to 3, negative 3. So we have these two different limits. Okay, and in fact, the actual value at 3, in fact, is different. The value is actually at negative 1. So this is important to understand that limits, first of all, we have to break them down to left-hand and right-hand limits. And limits are actually just telling me where I'm going. Okay, the limit does not tell me anything about what's happening when I actually get there. So this one here, as I approach from left side, it looks like I'm headed towards 2, but I end up at negative 1. So the limit doesn't have anything to do with this piece here. Okay, the limit has nothing to do with what's actually happening there. The limit only has to do with what's happening as I approach that point. And as I approach the 3 from this side, okay, so this is my right-handed limit, the limit looks like it's approaching negative 3. And again, it doesn't actually get to negative 3 because it actually goes to that value of negative 1. But again, that's not what the limit is for. The limit doesn't tell us what happens when I actually get there. It just tells me what's going on as I approach, as I'm trying to get there. It looks like I'm headed towards y equals negative 3. Now, this issue here, then, we can talk about a two-sided limit. So these are what we call one-sided limits, or left and right-hand limits. But as a two-sided limit, this limit does not exist, okay, because we are not headed towards the same point. We're not headed to the same spot from the left and right-hand sides. So the limit, as a two-sided limit, does not exist. Okay, so let's take a look at this point at x equals negative 3. Okay, this purple point here. So as I approach x equals negative 3 from the positive side, okay, as I approach it from the positive side here, it looks like I'm headed towards a y coordinate of positive 2. Okay, so my right-hand limit As x approaches -3, it's going to be +2 here. And I'm going to do the same thing from the left side. So as I approach it from the left-hand side, I'm approaching the same value of +2 here. Okay, so now what actually happens at -3 is that we go down to -3, right? It's way down here. So what actually happens at -3 is very different from what's happening from the left-hand and right-hand sides. But again, the limit has nothing to do with what's actually happening at the point. The limit is just telling you what's going on as you approach the point. And since the left-hand and right-hand limits are the same, okay, from both left and right-hand side, we can say that this has a two-sided limit. So anytime we don't have the plus or minus, this now indicates a two-sided limit. Okay, so this here, this indicates a two-sided limit. Okay, so as a two-sided limit, it does exist, right? So from the left side and right side, they're both approaching the same point. So we say the two-sided limit exists as y equals 2. So there's a couple issues here. The one-sided limits of left and right sides. Okay, the issue that the limit does not tell us what's happening at the point, it only tells us what's happening as we approach the point. And there's this issue of a two-sided limit when the left and right-sided limits both go to the same point. Okay, and we want to use these limits to help us understand what's going on at these strange points on functions. But we also want to know something about continuity. Okay, so there's, in this case here, it says something about continuity. So f of x is discontinuous. Okay, well, it means that if you take a look at this graph, in fact, anytime that we talk about continuity, we're just talking about whether as we're drawing, do we have to lift our pen up and put it back down again to draw. Okay, so there's definitely a discontinuity there. It's broken apart. And discontinuity and continuity is actually very simple if you just approach it from the visual standpoint. Does it break apart or does it stay together? So in this case here, at x equals -3, I do have to lift my pen up before I can start drawing again. So again, there's a break in the graph here, so it's discontinuous. Okay, so we're going to start looking at this issue of continuity a little bit later, but the limits actually help us establish continuity and discontinuities more formally.